So I want to go over number 14 on the spring 2016 final, and more than likely you'll have a problem like this on the final exam, so I want to kind of walk you through the process of it. It might not be a fence, but it could be something where you're going to maximize or minimize a cost function. So on a application problem, the first thing you want to do is you want to draw a picture of what's going on and write all the stuff that you know, right? So a farmer is going to want to build a fence, and the area needs to be 30,000 square feet. So area is 30,000 square feet. It's a rectangular fence, so I might just kind of draw a picture. So I have x, y. The formula for area on a rectangle is x times y, so I know that's going to be 30,000. The fence's area is to have one border shared with a neighbor who wishes it to be fancy, so he will spend $25 per foot on that side. So this x here, whatever we want to put, we say, okay, that's going to be $25 per square foot, or not per square foot, but per foot. And he will use $5 per foot on the fencing of the remaining side. So then let's say this remaining side is going to be $5. So dollars here. So if I want to write a cost function, what should the length of the fancy side be so the cost of the fence is minimized, right? So we're looking for x. So how would I write the cost function? Is going to be $25 times x plus 5 times y plus 5 times y plus 5 times x. All right, so put this in here, 5 times x. Okay. So simplifying here, I would have the cost is going to be 30x plus 10y. So at this point you usually have a cost function, or a function in terms of x and y, and a function in terms of x and y that's given. You'll want to solve for one of them. So let's say y is 30,000 over x. I'm going to plug this in to where my y is in this function, so I have a function only in terms of x. So here I'm going to put cost function is going to be 30x plus 10 times y, which in this case would be 30,000 over x. And then what I'm going to do here is differentiate this with respect to x to find maximum and minimums. So the derivative of the cost function with respect to x is going to be 30 minus 10 times 30,000, so I'll just go ahead and write 300,000, over x squared, and I want to set that equal to 0. So solving for this, x cannot equal 0. So I have multiplying through by x squared, 30x squared equals 300,000. All right, if I move this to this side, cross multiply, whatever you want to say there, I get x squared equals 10,000. So I take the square root of that, and I get x equals plus or minus, but talking about a distance, so it's going to be 100. So x equals 100 is my critical point, right? If I go to plug that into my derivative, the slope, right? So this is the cost function, the derivative. If I plug in a number, let's see, oops. If I plug in a number less than 100, let's say I plug in 50, I get a negative. If I plug a number greater than 100, let's say I plug in 101, I get positive. So I have a negative slope on the left and a positive slope on the right. This is a minimum. So that is telling me I have a minimum point at that point. X is what I wanted to find, so this is going to be 100 foot. It might ask you for the dimensions. If it wants to know the dimensions, you're going to plug x back in here. And y is going to end up being divided by 100 is going to be 300. So I'm going to minimize my costs by making x 100 and y 300. This is nice because you can kind of test, does the original area work out if I take x times y to get a? So hopefully this answers any questions you have there. On the final exam, you always want to draw a picture and write an equation and do the best you can, and you'll get partial credit there. If you have any other questions, please let me know.